function. I want to find the tangent.
Derivative of the integral.
Fantastic. Now, it doesn't matter what function you can have any curve you want, okay? If I draw a tangent line at any point, so I'm going to do it in blue here. If I draw at this point, I draw a tangent line, okay, and it touches that point once. This line here is a straight line. That has a certain steepness. That steepness is called your gradient. How do you find that gradient? Is the derivative of this graph at this particular x point. Okay, so I'm going to draw it again. So this point has an x coordinate. Whatever that x coordinate is equal to, I can find the derivative of the function at whatever that x equals to, and that will tell me my gradient. Once you know the gradient, the question is then, well, you need to find the y-intercept. Now remember, at this point right here, that has an x and a y coordinate. So for you to find out the y-intercept, if you found out the gradient already, you just need to sub in x and y to find out c. And that's what the first exercise is about, exercise 10A. Okay? So really the hardest part is just finding m. Once you find m, the rest is year 9 mathematics. Finding the equation of a straight line. You've got coordinates, you've got the gradient, find the y-intercept. Yeah? So back in year 9, what you would have done is a question would have said, if the gradient was 3 and the line passes through 1, 2, find the equation of the straight line. What you would have done is you would have went with the idea, you said, okay, well, y equals to 3x plus c, and you say, well, since when x equals 1, y equals 2, you would have said, all right, y equals 2, 3 times 1 plus c, and you get 3 plus c, 2, c equals 2 minus 3 on both sides, minus 1, therefore your equation is 3x minus 1. True? That's what you would have done in year 9, finding straight line equations. So they gave you gradient and a coordinate. The only difference in year 12 is they don't give you a gradient, they give you a function instead. Okay, they give you a function and, well, I don't know how to draw it. There we go. Okay, they give you a function and they give you a coordinate. And they say find the gradient or find the equation of the tangent line at this point. That's the same thing. At this point, they only give you an x coordinate, but you can find the y coordinate by subbing in to the function. You can find out m by finding the derivative, subbing x in, and you get the derivative, which is the gradient. So if you've got gradient, you've got the coordinates, you can do what you've done in year 9 to find out the equation of a straight line. Okay, so it's exactly the same. The only difference is how do you get those pieces or the puzzle. Okay, and that's what in exam 1, question 9 and 10, that's usually what this is going to be about. It's going to be a calculus question, and they can give you different types of functions. It could be an exponential, could be a circular functions. Your job is to find m at the coordinates. Find those two, back to year 9 maths. Okay, let's do an example. Does that make sense so far? Feel good? Yeah? All right, so let's do an example. I'm just going to take off that sound. There we go. Okay. Let's go. That's tangents. We'll talk about the normal later, but let's do this one. Actually, normal's there. Which one's the tangent? There we go. Tangent. All right, let's do this question here. It says, find the equation of a tangent line. Okay, so I've got a tangent line. It's a straight line. Okay, it's a straight line that touches this curve. I don't know what it looks like. It'll look like whatever you want it to look like. It's got a curve at the point on the graph where x equals 4. So if I were to illustrate this idea, it's exactly like what I just said before. I said, you can have a graph. Now, I don't know what this one looks like. I'm just going to make it up. I'm just going to say it looks something like that. I don't know. Just going to make it up. Okay? It looks like this, and it says, find the tangent line, the equation of the tangent line where, at the point where the graph is x equals 4. So at x equals 4, so here I go, I'm just going to draw a 4 somewhere. I'm going to say 4 is over here. So when x equals 4, this coordinate here, okay, so that coordinate has an x is 4. I want to find out y, because I want to know what that coordinate is. Now if I know x is 4, how do I find y? What do I do? How do I find the y coordinate? Sub in 4 into what? Yeah, see, this is the equation. It tells you, it says, I'll tell you what y is. Y equals 2, whatever you want x to be. Now in our case, we said x is 4. So your job is to figure out, all right, well, y will equal to 4 to the power 3 on 2 minus 4 times 4 to the power of half. Now you can do this on your calculator, you can do it by hand. I'll do this by hand, so just so that you can practice using exam 1, you are expected to be able to do these kind of questions. So 4 to the power of 3 on 2, a lot of students find this difficult, but you can break 4 into 2 squared, yeah? 2 squared gives you this. This is 2 squared, oops. 2 squared equals to 4 to the power 3 on 2 minus 4. Now this is the same thing, 2 squared to the power of half. Now we know from our index laws, what do you do to the powers? When you have 2 squared all to the power 3 on 2, what do you do to the powers again? Index laws, what do you do? So if I gave you, let's say, a to the power of 2 to the power 3, what was the rule again? What do you do? You multiply the powers together. Yeah, you multiply the powers together, so this becomes a to the power of 2 times 3, which becomes a to the power of 6. So the same thing here, you would say y is equal to 2 to the power of 2 times 3 over 2, minus 4 times 2 to the power of 2 times a half. Now notice when I changed it to squares, the halves cancel out. 2 times 3 over 2, the 2's cancel out, 2 cancels out. So I end up with, so since these 2's cancel out, I get 2 cubed minus 4 times, these 2 cancel out, 2 to the power of 1. So this ends up being 8 minus 8 is 0. Okay, now obviously I've drawn the graph wrong. So the coordinates at 4, 0, it should actually be over here. Okay? But I'm just drawing a picture just so you can picture what's going on. So you've got a coordinate, you've got 4, 0, and you've got a point. And what are you trying to find? You're trying to find the equation of a straight line. So this straight line is a tangent line. It crosses that point once. Now, I've drawn a tangent line very wonky there. Stand that was a straight line. Your job is to find that straight line. I found the point. Straight line is y equals mx plus c. I found a point. Now, remember what I just told you before. I said you need a point and you need a gradient. That's what you did in year 9. They give you a point and they give you a gradient, and your job is to find c. It's the same thing here. I found a point because I knew what x was. I subbed this in to get y. So I've got a y, I've got a coordinate already. My job is to find m. How to find m again? Back to year 11 maths. That's the only one thing we learned that was new. How do I find m? Jerry? Derive. Good. That's all I have to do. I have to derive this, and this is what I'm saying. Back to chapter 9. The better you were at chapter 9, you can find the derivative of this. So let's find the derivative. dy dx, let's work over here. dy dx of the function. You've got the function up here. Y equals x to the power of 3 on 2 minus 4 times x to the power of half. What is the derivative of this? Can I please have chi? Good. Half, good.
Minus 2x to the power of negative half.
Fantastic. Okay, so using a power rule there, drop down to 3 on 2, minus the power by 1, so 3 on 2 minus 1 becomes a half, minus times the half to the 4 becomes 2, and then half minus 1 is negative half. Okay, so power rule. Just using power rule there. Now I found the derivative. What next? Okay, so I found the derivative. I needed to find m. Now remember, the derivative only gives you m for every single point. Now I don't know which point I want, so what do I do next, Leah? Yeah, sub in 4. Because I said I want the derivative. I want to know the gradient at 4. See, because that gives me the gradient for every single point. But I don't want every single point. I want to know at x equals 4, what is my gradient? So I sub 4 in. I say, okay, sub at x equals 4, dy dx now equals to 3 on 2 times 4 to the power of half minus 2 times 4 to the power of negative half. Okay? And again, you can do this on a calculator, but I want you to practice doing it by hand because you're working with algebra here. Remember, there are 3 areas of study: calculus, functions, algebra. They're testing if you can do these. Can you use index laws? Can you work with surds? Can you work with fractions? Okay, so let's work this out. 3 on 2 times 4 to the power of half. We know that's really just square root of 4. So 3 on 2 times 2 makes it 3. So this now ends up being 3 minus... What's 4 to the power of negative half equal to? A lot of students struggle there. 4 to the power of negative half, what's that? What's 4 to the power of negative half? So 4 to the power of negative half, what's that equal to?
Half, right?
It'll be half.
Yeah.
How do you know?
Because it would be 1 over the square root of 4, which is 1 over 2.
Fantastic. Excellent. Normally at this point, remember every time you square root, there's a plus and a minus answer. But because we know, looking at this point here, we know that it's going to be a positive gradient. So I already know that it can't be a minus, it can't be, if it's smaller, it has to be a positive value to keep it positive. Yeah? So right here we've got half, and we then say, all right, well then that means if this is a plus half, we've got minus 2 times the half, and then half becomes 1, so 3 minus 1 is equal to 2. Okay? And so my answer to this question would be, since that's y equals to 2 times x, because that's my m, I've got plus c, which I still don't know. So I did all this work. I did x, sub in to find y, I found a coordinate. I found the derivative, I sub 4 in to find the gradient. How do I find c now? I got y equals 2x plus c, I've got a coordinate, I've got a gradient. Back to year 9 maths now. How do I find that? Yeah. In year 9 we said, all right, well if I'm given a gradient, I'm given a coordinate, to find c, sub in x, sub in y. Okay, so at that point I'll say, all right, if I sub all that in, I'm just going to follow this and delete that. This now becomes y0, 2 times 4 plus c, 8 plus c equals 0, c has to equal to negative 8. Therefore your equation is 2x minus 8. Okay. I'm just going to double check this point here when you square root whether you can have a negative gradient as well. Because I made up this graph, remember that. So there might be 2 points. But because if it comes back down, you might have another point at x equals 4 in the tangent. So let's just double check that. There is an answer there. You may have 2 points. Was that square root of 4 negative, so it was half or negative half? So if it's negative half, it becomes 3 plus 2, which is 5. Alright. Well then 5 times 4, so you can either have y equals 5x minus 20. That's another one there. Alright, let me just double check. So the other way to double check now is, do you have 2 points? Because I made up this graph, just for argument's sake, but if you really want to know if you do have 2 tangent points for the one x value, that only happens if you have a graph that comes out like this. So that means that you've got a tangent line at x equals 4 and another tangent line at x equals 4 here too. Okay? So the only way is sketch the graph, see if it actually happens. Okay, so be careful when you square root, there is a plus and a minus answer, but then that would be a relation, yeah. But they never specified, they just said find the equation of a tangent to the curve. They didn't say it's a relation, they didn't say it's a function, and they didn't give me any restrictions. So you just got to be careful. So these are things that when you're working with it, you got to pay attention to those. When you're doing your SACs, those are the questions you got to ask yourselves. You can't just jump to the answer and say it's got to be positive. Every time you square root, you got to question, has there been a restriction in my application? Does it make sense to have a negative or a positive value? In our case, we didn't have any restrictions. It wasn't an application sort. So that's why I'm sort of iffy. It depends if there is or there isn't. So the only way to check is check the graph and see if there are 2 points. If there are 2 points, there are 2 equations. Does that make sense? No? All right, I'll draw the graph. I'll draw the graph and then we'll see if there are 2 points.
This is like a non-case. How do you check?
Well, non-CAS, they have to put restrictions. Yeah, and if they put that type of question, I would be safer to put 2 answers. Because I'd say square root of 4 is plus or minus 2. So you have a plus half and a minus half. So you're meant to get 2 answers. And they didn't give me any restrictions on what x could be. So technically I'm not wrong on a technical basis. So that's what I would do. But just in case that I'm teaching you wrong, so I'm just going to do x to the power of 3 over 2. What's this? This is minus 4 times x to the power of 1 over 2. Yeah, what? No, that doesn't make sense. X equals 4. No, it looks like there's only 1. So I don't know why there should be 2.
got the derivative equation, right? You've got 3 over 2 times 4 to the power of half. And then you have to square that as well. So that would be positive 2 and negative 2.
Oh.
So then you have to make it.
Oh, yeah, that's true. I forgot about this one. So if it was plus half, oh yeah, right.
Because they start, that would be negative 3 plus.
All right, let's do that properly. Just in case. Maybe it ends up being the same. All right. Let's check that. So let's say if the square root of this was meant to be negative half, then you get negative 3 minus 2 times negative half becomes negative 3 plus 1. Did I do that wrong? No. You get 2 different ones. Oh. I don't know why you get 2 different ones. I'll think about that. I have no idea. It shouldn't be different. It should be the same. Yeah, can't figure it out. Let's go next one. Here we go. Example 2. Let's go back to this point here. It says find the equation of the normal to the curve with the equation y equals x cubed minus 2x squared at this coordinate. First question is, anyone know what the normal means? What's the normal again? What is this called again? Yes.
Like a perpendicular line to the tangent.
Good. Perpendicular line to the tangent. Now, if it's perpendicular, in year 9, we only learnt one thing, one property to know if it's perpendicular. What do we use again? If it's perpendicular, what property do we use? Yes, Jack.
Together they have a gradient.
Together, when you say together, you mean add, subtract, multiply, divide? Multiply. Okay, now if 2 lines are perpendicular, their gradients when they multiply to each other has to equal to negative 1. Okay, so that's the property that we use for perpendicularity. So m1 times m2 has to equal to negative 1. So the 2 lines, the gradients, if they are perpendicular, which that means normal, perpendicular means that both the gradients will multiply to give you negative 1. Now, if I were to draw this picture, just as a rough idea, okay, it's a cubic function, and I want to find at 1, negative 1, find the equation of the normal line. So let's say at 1, negative 1, let's say this is 1 and this is negative 1 here. Okay, at that point, I've got a tangent line, so I'm going to draw my tangent line. Here we go. Got a tangent line that looks like that, so it touches that surface at 1 point, and my job is to find, this is the tangent line, my job is to find the normal line. So not the blue line, I'm trying to find the equation of this line. Okay, and that's perpendicular to that point. So at this point it makes 90 degrees. So the question is, how do I find the green line? This is y equals mx plus c. They're giving us a coordinate, we've got 1, negative 1. How do I do this?
Wouldn't you just divide the equation and that m would be the first m of the m1?
Fantastic. Okay. We know that we can find the gradient of the blue line because that's a tangent line. That's all we ever learned. In year 11, we found out that the derivative at this point, we can find out this one. We can find the gradient of this. Because the derivative of this graph at this point will give me the gradient of the tangent line. Yeah? So I can find m1. If I know m1, I can find m2. Because once I know m1, divide both sides by m1, I get m2. Right? So once I have m2, and I've got the coordinates, I can find c. So what I'm doing there, they're all just sort of stepwise process. You're moving in that puzzle. Yeah? So let's do this first. We're going to find out the derivative, dy dx. Now, what's the derivative dy dx, Naz, of x cubed minus 2x squared? What is that? Fantastic, minus 4x. So this is my derivative, but it doesn't tell me the gradient at this particular point. So how do I find the gradient at that particular point, Phoenix? Fantastic. It's always the x values, not the y values, yeah? So we're looking at this, we're saying at x equals 1. We know that at x equals 1, this will tell me the gradient. So dy dx at x equals 1 will be 3 times 1 squared minus 4 times 1. That gives me 3 minus 4, negative 1. So what that tells me is this gradient is a negative 1 gradient. Okay, so I have now that's negative 1. Now that I know m1 is negative 1, I can go back to this drawing board and say, well, that's negative 1 times m2 has to equal to negative 1. Logically, how do you find m2? Divide both sides by negative 1. Yeah, to remove the negative 1 here, and you get m2. So m2 now, logically, has to equal to 1. Okay, so negative 1 divided by negative 1 gives you positive 1. So now I know the gradient of this green line, or the perpendicular line, is, 1. So I got my equation here. I'm just going to write it over here in green. So you can see in green, I've got y equals to 1x plus c. How do I find c? Luke?
Of 1, negative 1.
Good, because they both cross. See the intersection, this is the tangent line at that point, and also this perpendicular line crosses that point as well. So they have 1, negative 1 on that line. So I can solve when x equals 1, y equals negative 1 to the equation to find c. Okay, so it is possible to do because they do cross at 1, negative 1. So at 1, negative 1, you got negative 1 equals 1 times 1 plus c, and that works out to be negative 2. Okay, therefore, y equals to 1x minus 2 is the equation of my normal line. I wasn't trying to find the equation of my tangent. I was trying to find the equation of my normal line. How was that? Pretty easy? Okay, and that's really just applications right there. You see, everything that you needed was year 9 algebra, and then you've got calculus from year 11, and we did chapter 9. That was everything you needed to know. And that's what chapter 10 is. They're going to revise on your chain rule, product rule, quotient rule, power rule, circular functions, exponential logs. You have to be able to find the derivative of all that. But at the end of the day, that's all you're doing. Okay, so it doesn't matter what graph you get, the concept's the same. The graphs can change, but the theory is the same for every one of them. You're finding the tangent, find the gradient, find the y-intercept. It's the same job. Yeah. Cool? Right, I'll leave you on to just exercise 10A just to practice. The next few exercises just talking about stationary points. We can whip through that really easily, but I need you to work on that, okay? Because that's the application. That's where most of the questions come in, like for you to think about how to answer it in your exam 1. Exam 1, that's what they're testing. They always test that, okay? I'll find one that's more relevant. You can have a go with this one if you want. That's more of a 10C problem. But it's something similar to what's required for you to do at the end of year, exam 1. Find A, find B, find C. Try to picture what you're doing there. I'm just going to pause the video, and then I'll go around and help.